Hello students, good morning to all. Welcome to your beautiful channel Firjan. Today concept is battery connected to the capacitor. What now here? It has capacitance C naught, charge Q naught, potential V naught. When battery removed and dielectric inserted between the plates, what are the changes? How electric field changes, either increases or decreases? Potential either increases or decreases? Capacitance either increases or decreases, potential energy either increases or decreases, that we discuss. And one more, battery connected. After connecting the battery to the parallel plate capacitor, dielectric inserted. What are the changes is there? Electric field changes or not? Potential changes or not? Capacitance increases or decreases? And potential energy increases or decreases. How changes potential, capacitance, electric field and energy? So that we discuss when battery connected and dielectric inserted, when battery removed, dielectric inserted. These two cases we discuss. First case na, case 1, see battery removed and dielectric inserted. See here, it is the parallel plate capacitor. See, it has parallel plate capacitor. See here, it is connected to cell. It is the cell, it is connected to cell or battery, it is positive, it is negative. Here see, current is flowing this direction. So because of this battery is what? Energy supplied source. Because of this energy, it will take electrons from this plate and reaches to here, reaches to this plate. Means here taking charge na, so plus we can get, here minus we can get. One more charge taking here and reaches to here, we can get minus. Here taking charge again, here placing, so one more charge, so one more charge taking here, placing here. What happened here? This place develops a positive charge, this place develops a negative charge. See, means here what now, this one plus Q naught, it is minus Q naught. Why we are taking Q naught na, maximum charge? Why now? Here initial charge, that means, see here, here how much positive charge is there? Same magnitude negative charge is there, but opposite only, but charge will be here plus, here minus. See here, when battery is connected, it will happen. So what is the capacitance now here? C naught. Potential is V naught. So when battery connected to the parallel plate capacitor, charge is Q naught on one plate, another plate is minus Q naught, capacitance C naught, potential is V naught. When battery removed, see for example here, it is the parallel plate capacitor, battery removed and dielectric is inserted. It is the dielectric, it is inserted. Here what we have? Positive charge. See here negative charge in one plate. So but both are in same magnitude. See battery removed. See here battery connected. Sorry, battery connected here, battery removed. This case here what is the charge? Q naught. Here Q naught, but here minus, here plus. See here positive charge. Because of positive charge and negative charge, electric field is developed. From where to where? Positive charge to negative charge. It is the external electric field, that is E naught. Because of this external electric field E naught, some charges are polarized in the dielectric. Why? Because dielectric is the special case of material. It is not a conductor, not insulator, not semiconductor. It is different class of material. Due to that, it does not allow current. It allows development of electric field. It allows only development of electric field, does not allow current. See, due to that, in this one molecules atoms is there. In this molecules and atoms charges is there. These charges will be polarized. Positive charges will be one side and negative charges will be one side. See here positive charge na, here develops negative charge, here see negative charge developed. In this one develops positive charges. So this positive and negative charges in this one also means induced electric field is developed. So that is always opposes the external electric field. So means when dielectric inserted between the parallel plates, what happened now? When battery removed, what now? Charge is Q naught here, here also Q naught, means Q naught means Q charge is constant, charge is not changed. Yes na? Only here potential changes. When battery removed from the parallel plate capacitor and dielectric inserted, what the main changes? Q is not changes, means charge is not changed. Only what changes? Potential is changed, either increases or decreases, electric field either increases or decreases, energy either increases or decreases, capacitance either increases or decreases. That we discuss. See here, because of this positive charges, negative charges pulling downwards, because of this negative charges, positive charges attraction, so this dielectric is moving downwards. So because of this electric forces, yes na, it will be moving downwards, its speed changes. So speed change na, so everything will be collapse. So that's why what we are doing now here, we are applying F external. So means external force is applied. This external force is approximately equal to electric force, downward force. So here external force is applied. So external force is upwards, dielectric is moving downwards, displacement is minus, external force is upwards. Yes na, this case what happened now here, what are the changes we are absorbing after dielectric inserted? This dielectric is moved slowly because of we are applying external force, that's why it will be moved slowly, no change in speed, no change in kinetic energy, change in kinetic energy is zero. So that's why here it will be moving slowly downwards because of this external force applying against electric force, not equal exactly, approximately equal. Yes na, it will move slowly. Yes na, so no change in speed, no change in kinetic energy, like that it will move downwards. See this case slowly moving, that case before dielectric inserted, after dielectric inserted, what are the changes we are observing? First one, see what are the capacitance. Initial capacitance is C naught, this capacitance is C naught, initial capacitance. See here, what is the capacitance now? Initially C naught. So before connection, after removing connection, dielectric inserted, what is the capacitance? C final equal to K C naught. Why we are writing K C naught now? When dielectric inserted between the parallel plates, we know already dielectric make the capacitance to reach K times. Dielectric, I know, we know that one. So dielectric make the capacitance to reach K times, it increases K times capacitance. So that's why final capacitance is Kc naught. When dielectric inserted between the plates, what about capacitance na? K times increases, so Kc naught. What about initial charge na? Q naught. Final charge also Q naught. Why now we know? So when dielectric means battery removed and dielectric inserted, charge constant. Potential only changes, either increases or decreases, we only find out. See here, what about potential na? Potential initial is V naught. What about final? Final potential na here. See, potential equal to what na here? We can write charge by capacitance. What is the charge here? Q naught. Of connection also Q naught. After removing connection and dielectric insert also Q naught. So here we can write Q naught. Charge is Q naught. Capacitance na initially is C naught. After inserting dielectric, what is the capacitance? Kc naught, means here 1 by K, Q naught by C naught, we call it as potential. So means here V equal to what? V naught by K, means potential decreases K times when dielectric is inserted and battery removed. This case capacitance increases, sorry, and capacitance increases and potential decreased by K times, means it decreases, potential decreases K times when dielectric inserted, battery removed and dielectric inserted. What about electric field? See, initial electric field na E naught, this one. So when dielectric inserted, this E naught, what happened now here? See, it will change as to what is this is initial electric field. After inserting dielectric, what now electric field? See here, electric field equal to what? So means V by D. Electric field equal to what? V by D. Why? Because V equal to ED minus ED, we can take magnitude na. So means V equal to ED. From this V by D. What is V? Capacitance increased by K times when dielectric inserted, K V naught by K into D. What we can get now here? See, 1 by K, V naught by D means E naught. So we can write here E naught means electric field is decreases to K times. See, when dielectric inserted, what na? electric field also decreases. Potential decreases, electric field also decreases. Means E final I write here. What is now here? E naught by K. So means electric field also decreases. So potential decreases, electric field also decreases K times, means E naught by K. What about energy? See, means potential energy, means electrostatic potential energy. What is initial now here? Actually potential energy formula is Q square by 2C. Here initial charge is Q naught, initial capacitance is C naught. That's why what is the initial potential energy developed in the capacitor na? Q naught square by 2C naught. For example, see here, what is the final potential energy? See final potential energy na, see energy means Q square na, Q means same, Q naught square. Capacitance increases K times, so that way 2 Kc naught. What we can write here? 1 by K Q square, Q naught square by 2 C naught. Means potential is increased by how much na? Here I write final potential, so that is 1 by K into Q naught square by 2 C naught. Means potential is decreased K times. Potential also decreases, potential energy decreases, but electric field decreases. Means battery removed and dielectric inserted. What are the changes we observe now here? Capacitance increased K times, potential decreased K times, electric field decreased K times, potential energy decreased K times, and only charge is constant. Charge is constant. See here, when battery removed and dielectric inserted between the parallel plates capacitor, what now here? Capacitance increased by K times, charge is same, constant, potential is decreased by K times, V naught to V naught by K, electric field decreases K times, E naught to E naught by K, potential energy decreases K times, Q naught square by 2 naught C2, C2 is 2 C naught to Q naught square by K 2 C naught, means K times decreases. Yes na? What is na here? Work done by external agent we can write here. See, potential energy decreases, where it will go this potential energy? So that now we see here, work done by external agent. See, work done na upwards, so displacement downwards. Why not here? So due to electric force, dielectric is moving downwards, its speed increases. For decreasing speed means whenever it will be moving downwards, speed will be constant only. For that we are applying external force and pulling outwards, which is nearly equal to electric force. Then only it will move slowly. No change in the potential and no change in speed. Change in kinetic energy also not there. So change in kinetic energy is 0. Then it is okay. So that's why external force is acting, which is approximately equal to electric force. So what is the external force here? Upwards. What is the displacement? Downwards. Work done by external agent is, external force is F external, displacement is here what? Opposite to external force, so minus. So means what here? Work done by external agent equal to minus of force into displacement, minus of force into displacement. This negative indicates work, means here we are doing work, means in this case negative indicates na energy is obtained. So obtained means here energy is gained by us. Why na? Here what happened here? Potential energy Q naught square by 2 C naught initially, finally what here? Q naught square by 2 C naught into 1 by K, means potential energy decreased K times. So how many times it decreases, that much energy we are gaining from this, due to we are doing external force. So that means how much energy decreased here? Potential energy, that much energy we are obtaining. So that's not here. Why now? How we can do now here? Work equal to what? Change in potential. So change in potential means U final minus U initial. What is U final? So 1 by K Q naught square by 2 C naught minus Q naught square by 2 C naught. See here, Q naught square by 2 C naught common, 1 by K minus 1. See here, K means dielectric constant. For air or vacuum na 1. So other material definitely greater than 1. So we can take here 2. What we get here? Q naught square by 2 C naught, 1 by 2 minus 1 means 2, means minus 1 by 2 we are getting into Q naught square by 2 C naught. means how much here decreased, that much we are gaining. Why now? We are doing external work and the dielectric is moving downwards. Because of that, due to external work, we are gaining energy. Energy is gained. How much we are gaining? That much energy is decreased while dielectric is inserted between the parallel plates. Yes na? See, battery removed and dielectric inserted. What are the changes we are observing now? Charge is constant, potential decreases k times, capacitance increases k times, potential energy decreases k times, and electric field also decreases k times. How much energy decrease? That much energy we are gaining while doing external work on the dielectric, and it is moving slowly downwards. So that case we are doing some external work, that case we are getting the energy. Where we are getting now, it has initially it has potential energy. While inserting the dielectric, some energy is losses. That energy will be we obtained because of we are doing some external work on the dielectric. So that means energy how much decrease, that much energy is obtained. Here a negative now work means here energy is obtained. So this is the concept when battery removed and dielectric inserted. Yes na? So capacitance increases k times, electric field decreases k times, potential decreases k times, energy decreases k times, but charge is maintains constant when battery removed and dielectric inserted. Yes na? It is the concept involved in battery removed and dielectric inserted. Now we discuss battery connected and dielectric inserted. What are the changes we can do? So that we discuss. So before that, force also changes or not. So that also we discuss. Later we can go the dielectric battery connected and the dielectric inserted. See, while battery removed and dielectric inserted, what about force change? We discussed before. Capacitance increases k times, electric field decreases k times, potential decreases k times, energy decreases k times. That energy will be we obtained. Why? Because we are doing external work. So energy is obtained by us while dielectric inserted and battery removed. In this case, what about forces? For example, see here, it is the dielectric, sorry, parallel plate capacitor. It is a positive charge, it is a negative charge, it is Q naught, it is Q naught, it is minus, it is plus. Electric field is, this is the direction of electric field. See, E is the electric field. See here, what is the force acting on second plate? We find out here, force on second plate due to first plate. See what now here, we write Q into electric field. What is the electric field? See, electric field on second plate due to first plate, that is E21 we can write. Electric field na between the parallel plates, what's the formula na? Sigma by epsilon naught. Sigma means surface charge density. Sigma equal to surface charge density, charge per unit area. What is the charge now here? Q, unit area, and epsilon naught. So means Q by A epsilon naught is the electric field between the plates. So means here electric field on second plate. It is the second plate, it is the first plate. Electric field on second plate due to first plate na. What is the electric field now? Q by A epsilon naught. See, now we can write force on second plate due to first one. See here, F21 means force on second plate due to first one, due to first plate. Here E21 means electric field on second plate due to first one. Yes na? See here, force on second plate due to one, force on second plate due to one. What na here? Q into E21. So what is Q here? Charge is Q. Yes. So electric field is what? Q by A epsilon naught. See here, one more important. Force on second plate due to first plate, what we can write? Q into E. Force on second plate due to first plate. Electric field on second plate, see here, electric field on second plate due to first one, means here electric field is acting on one plate only. Two plates is na sigma by 2 epsilon naught. Single plate na here we can write 2 epsilon naught. Sorry, what is the electric field on second plate due to first plate na? Due to this plate, electric field on one plate only, single plate. Electric field on single plate na sigma by 2 epsilon naught, not epsilon naught. Parallel plates na sigma by epsilon naught. Single plate na 2 epsilon naught. What we can write here? 2a epsilon naught. Yes na? Sorry. See, electric field on second plate due to first plate, means single plate here, not parallel plate. Parallel plate na sigma by epsilon naught, two single plate na here E21 equal to sigma by 2 epsilon naught q by 2a epsilon naught. So electric field on second plate due to 1. See here what we can write here, 2 epsilon naught. Here charge is q, electric field on second plate due to first one. So what, q by a epsilon naught, here q. What we can get here, q square by 2a epsilon naught. It is the force on second plate due to 1. What is the force now? Q square by 2 epsilon naught a. It is the force on second plate due to first one. Due to first one. Now we can discuss. So dielectric inserted between the plates. It is plus, it is minus. Yes. In this case, dielectric inserted. This case, what is the force? Changes or not? So that we discuss. Force is changed on plates or not? So that we discuss. See here, electric field na external. It is due to this here minus is developed. Due to here plus is developed. See here, electric field on second plate due to first plate and dielectric we find out first. Electric field on second plate due to all plates. All plates means here we have remaining is there, first plate, dielectric is there, dielectric negative, positive is there. Because of this three, what is the electric field on second plate? That we can write. Electric field on second plate due to all plates. What now here? Electric field on 2 due to 1, we can write 2 1. Electric field on plus q, we can write here, we can write minus q. Yes na, minus q. Due to minus q, what is the electric field here? Minus. What is the electric field due to plus q? So that is electric field on due to plus q on second plate. Yes na. See, electric field on 2 due to minus q, electric field on 2 due to plus q. Yes na. See, we can write electric field on 2 na due to single plate na. See here, sigma by 2 epsilon naught. I write here sigma. See, electric field on single plate equal to sigma by 2 epsilon naught. So we can write here sigma by 2 epsilon naught. Yes, here minus sigma by y, because individual electric field this one, it is also individual electric field. Sigma by 2 epsilon naught, sigma I by 2 epsilon naught plus sigma I by 2 epsilon naught. See here, sigma I by 2 epsilon naught, sigma I by 2 epsilon naught cancel. What we get here, sigma by 2 epsilon naught. Sigma means charge per unit area, so means into 2 epsilon naught. What is the electric field on second one? Due to all plates na, q by 2 epsilon naught a. It is the electric field on all plates. It's not electric field on second plate due to all plates. What is the electric field? Q by 2 epsilon naught. What about force? Force on second plate due to all plates. What now here? So you see Q into electric field now. See what is Q here? Capital Q. Electric field now here, Q by 2 epsilon naught A. See what now here? Q square by 2 epsilon naught A. It is the force on second plate due to remaining place, plus q minus qi plus qi. This all, what is the electric force na? Q square by 2 epsilon naught. Due before electric means dielectric, what is the force on plates? Q square by 2 epsilon naught. After inserting dielectric, what is the force? Q square by 2 epsilon. Means force does not change on plates. Force is not changes. What changes here? Force transfer or changes, means force changes between the plates. Force changes between the plates, means force is no change. See, when dielectric inserted between the plates and battery removed, that case capacitance increased by k times, potential decreased by k times, electric field decreased by k times, potential energy decreased by k times, charge is constant, force also constant. Force is transfer between the plates, I mean changes between the plates, but force on plates is, force does not change on plates. What is the force on plates now? Q square by 2a epsilon naught. Here also see, after inserting also Q square by 2 epsilon naught e. So means force does not change on plates, it is changes between the plates, means transferring this plate to that plate is here transfer. Yes, now that is battery removed and dielectric inserted. Now we discuss battery connected and what are the changes we observe. So that we discuss. See battery removed. Now we discussed. So battery connected and dielectric inserted. See here, it is the capacitor. See, it is positive charge. How developed we know already. Yes, now here minus. See what is the charge here? Minus q naught. Sorry, plus q naught. Here minus q naught. See, electric field is, this is the direction of electric field. Initial electric field now E naught. Initial capacitance C naught. And battery connected. Yes, see, battery connected. This case charge is q naught. Capacitance is C naught. Electric field E naught. Potential is V naught. Why we are saying V naught, E naught, Q naught and C naught? Na? Initial capacitance, initial electric field, initial charge, initial potential. See battery connected, what? Second case, battery connected and dielectric inserted. Now we are taking, so battery connected is there, connection is there. Yes, see, in this case, charge is developed. What is the charge here? Plus Q naught. Here charge is minus Q naught. It is plus. Yes, it is minus. Yes, see, here capacitance C naught is there. Potential V naught is there. In this case, see, in this case, dielectric is inserted. It is the dielectric. It is inserted. When dielectric inserted between the plates, definitely charge is polarized. So means here minus charge. Yes, here plus charge. Because of in this one some atoms and molecules is there. Atoms and molecule charges is there. That all positive charges one side polarized. All negative charges one side polarized because of external electric field. Yes, now here it is induced charge qi, it is q means q plus qi, this one plus q plus qi, it is plus qi, it is minus qi, means induced charge. Because of this electric field is developed. Yes, now so that is this direction electric field, here this is the direction of electric field. See here, due to negative charge, here positive charge is pulling downwards. Due to negative charge, here positive charge pulling downwards, means force is acting downwards. What that electric force? So means here it is pulling downwards and its speed increases, but our condition no change in the speed. When change in the speed, na total potential energy all develop means collapse. So that's why electric field, due to electric field, it will moving downwards and change means speed is changes. So no change in speed. That's why what we are doing here, external work we are doing. So due to external work, this external force is acting on the dielectric and external work is done. So and pulling outwards, we are pulling outward dielectric. What na? How much external force we are applying, that much is electric force. Means approximately equal, not exactly equal. Exactly equal, not moving downwards. So approximately equal. So then, so dielectric is moves slowly downwards. Yes, now this case, what now here, work done by external agent. Now we can write, see force external, yes, displacement is minus x. Why we are taking minus? Now downwards moving, work is upwards, external force is upwards. So we can write here f into x. So means negative work. So means here energy is obtained. How it will obtain? What about energy in the capacitors? What is changes in the electric field? What are the changes in potential? What are the changes in charge, energy? That are all we discuss now. See here, before connection of or before inserted dielectric, after inserted dielectric, what are the changes? That we discuss. See here, initial capacitance, what? C naught. Final capacitance, we know, C Kc naught. Why? Because when dielectric is inserted between the plates, definitely capacitance increases K times. What is why now? Dielectric make the capacitance to reach K times. Yes, when dielectric inserted, capacitance automatically increases K times. That is the main concept. Yes, na? Here see potential. What na here potential? Initial potential here V naught. Final potential na V naught only. Why na here? Initially V naught. See here, when dielectric inserted, battery connection is there. What is the constant now here? V is constant. So means battery maintains constant potential always and charge only changes. Charge changes. Battery removed and dielectric inserted, charge constants, potential changes. But battery connected, dielectric inserted, potential is constant, charge only changes. What changes that we discuss? Here is potential is same, final potential also. What? V naught. What about charge? See final charge. Initial charge is Q naught. What is the charge? See here, charge equal to what now here? CV. Q final equal to what is C? C naught to K C naught. I write here K C naught. What is the potential? V naught. Here also V naught. We can write here K into C naught V naught. C naught V naught means Q naught only. So means final charge is KQ naught. Means when battery connected, dielectric inserted, charge is increased k times. Charge is increased k times, kq naught increases. Yes na? Charge increases k times. Potential constant, charge increases k times. When charge increases k times, what about electric field? See here, initial electric field is E naught. What is the final electric field? We can write here final electric field now. Here see, electric field means V by D. Yes na? So final electric field na, what is the final potential? V naught. Or we can take another one formula, that is, see, we can write electric field equal to V by D. One formula is there, sigma by epsilon naught 1 is there. See here, here electric dielectric is inserted. What about electric field? Here now he, see, dielectric inserted, what now here, sigma by K epsilon naught. Means here sigma by K epsilon naught means it K times increases. See here sigma by K epsilon naught. So sigma means Q KQ naught by A into K epsilon naught. Understood this point? See, when capacitor means in between the capacitors means parallel plate capacitor, dielectric increases, electric field is sigma by K epsilon naught. So sigma is what here? Surface charge density, charge per unit area. What is the charge here? KQ naught. By dielectric inserted, charge is K times increases by A. So means what is the capacity here? K epsilon naught. So K cancel. What we get here? Final electric field is Q naught by A epsilon naught. So what here? Final electric field. I write here. Final electric field is what? Q naught by epsilon naught A. Means electric field also not changes. Here see, capacitance increases K times, potential same, charge increases K times, but electric field not changes. Why now? Here when battery connected and dielectric inserted, here Q naught is increased to, see here, what is the change in charge now here? KQ naught minus Q naught means what here? K minus 1 Q naught means charge is increased K times. How many times increased charge? That much electric field is developed. So because of that balances. So that's why electric field maintains constant, potential constant. Means when battery connected and dielectric inserted, electric field also constant. Electric field constant and potential constant. Only changes here, charge changes. Charge increases K times, electric field decreases K times. Here charge increases na, electric field decreases. So both are balanced. What here? So it maintains constant electric field. Constant electric field. What about energy na? Ui equal to what na here? Half CV square C naught V naught square. Potential energy formula is here half C naught V naught square. What about here final potential energy now here? See, final potential energy is half C means KC naught V naught square. V naught is constant. So what we get here? K into half C naught V naught square. Means here C potential energy also increases K times half C naught V naught square. It is also increases. Means when battery connected, dielectric inserted, capacitance increases K times, potential maintains constant, electric field maintains constant, charge increases K times, but potential in energy also increases K times. Here see, work done by external force now. See here what? Minus we get means energy is obtained. Energy is obtained. So energy obtained here. Here also energy increases. Before battery removed and dielectric inserted, how much energy is obtained? That much energy is decreased. But here also energy obtained. Here also potential energy increases. So by inserting dielectric, actually potential energy is decreased before battery removed and the dielectric inserted. But here battery connected, dielectric inserted, energy we are gaining some energy while doing external work, and potential energy also increases. Why it will happen na? Because of battery. So means battery supplies energy. See here, when battery connected, what happened now here? So charge is supplied, this one means charge is increases. Because of charge increasing, what now happen here? Potential energy also increases. See here, so it means here taking L means some charge and place here. What happened now here? This Q naught is changes to KQ naught. When KQ naught changes, here potential energy developed increases, and whatever the work we are doing, we gain some energy. So means both cases increases. Energy gained and potential energy also increases when dielectric is inserted between the plates and the battery is connected. Why now here? Energy supplied by battery means work done by battery equal to what now? Charge into potential. What is the charge here? See here, Q naught into K minus 1. What is the V? V naught. So Q naught means here C. Q naught means C naught V naught na into K minus 1. Here V naught is there. What? C naught V naught square we can get K minus 1. For example, here dielectric is more than 1, so means 2 we can take. What we get now? C naught V naught square we can get. What is the energy supplied by the battery na? What? C naught V naught square when dielectric inserted. So this C naught V naught square na, here na, energy is supplied. This energy is distributing energy gained and energy means potential energy developed in the capacitors when dielectric inserted. Both are increases. Why na? Because of energy supplied by battery. This energy is equally distributed. For external work some energy, half energy. For increasing potential energy, half energy increase. That's why, for example, battery supplies 2 joules of energy. 1 joule is gaining, 1 joule is increased by potential energy. Potential energy increases 1 joule. So this will happen when battery connected and dielectric inserted. How they are asking question now? When battery connected, dielectric inserted, battery supplied by the energy is 10 joules. What is the energy gained by external work na? Half of energy. 10 joules supplies na? 5 joules. What is the potential energy developed in the capacitors na? 5 joules. Means they are not giving any value, but they are asking question. What about potential energy? How much potential energy is increased when battery connected and dielectric inserted? Means battery supplies 2 joules of energy. What is the energy developed in the capacitors when dielectric inserted and battery connected na? Half of the energy supplied by the battery. What is the half of energy supplied by the battery? 2 joules supplied, so means 1 joule. So what is the answer now here? 1 joule. Like that they are asking questions in JEE and NEET exam. So please see the videos, like and subscribe the channel and share to your friends and relatives. Thank you. It is, I think, very good concept. Please see the videos and subscribe the channel. Thank you.